Hey everyone, it's Bob Crossan. I'm the editorial director for Wastewater Digest. I'm joined today by Bryan Buchanan, wastewater utility manager for the City of Roseville, as well as Devin Whittington. He is assistant director for environmental utilities for the City of Roseville. And we're going to be talking about the Pleasant Grove Wastewater Treatment Plant and its renewable natural gas strategy. So thank you both for being here. I appreciate you guys taking the time. Can you tell me a little bit about your plant's service area, Bryan?
Sure. So the City of Roseville actually owns two regional wastewater treatment plants, the Dry Creek Wastewater Treatment Plant, and then the plant that we're talking about here, the Pleasant Grove Wastewater Treatment Plant. The plants serve all of the City of Roseville, but they also serve the City of Rockland and part of this area called Loomis, and then also parts of Placer County. So we're a regional facility treating all of the wastewater from that region, about a little over 200,000 residents.
Oh my, that's a pretty sizable group of people that you're serving.
So no, we in both between the two plants, we have an average dry weather flow of about 17 million gallons per day.
Okay, cool. So, could you describe kind of the flow of the plant? Like how does water enter the facility? What is your treatment process at the actual plant, like in the order of operations there? And where does it eventually discharge to?
Okay, so a good question. So the wastewater enters all in one location, a large diameter, 96 inch diameter main that comes into the plant. Then it's pumped up into a grit chamber, and from that point forward it flows gravity through the rest of the plant. And so it's a what we call an extended aeration plant. We have oxidation ditches, we have primary treatment, and that's part of what we just added. So the first step in the process is primary sedimentation basins, where we settle out the normal process of settling out solids, and then from there it enters our extended air oxidation ditches. That's where our secondary process takes place. And then, it's a unique at the time when it was first built for this part of the country. And then from there it goes into our secondary clarifiers, and it settles out the solids. And after that, it's almost done. It goes through tertiary filters, and then goes through a UV disinfection process, and then it's either sent into our recycled water system, pumped into our recycled water system, or what's not recycled is discharged to Pleasant Grove Creek, hence the name, the Pleasant Grove Wastewater Treatment Plant. So it is all discharged, what we don't use for recycled water, out to Pleasant Grove Creek, and that eventually flows out toward the Sacramento River.
So for your recycled water, sorry to just ask this additional question here, is that for mostly like irrigation things and things like that? Or like where does that water go when it's recycled? How is that used?
So we use it mostly for irrigation. We have 4 golf courses, and then we have parks and schools, and it's all landscape irrigation. And we do have one industrial customer, the Roseville Energy Park, which is just north of the Pleasant Grove treatment plant, and they use the recycled water for cooling water in their process.
Oh, very cool. I love hearing the fit for purpose water stuff that wastewater plants are doing these days. So I had to ask about that. One of the things that brought me to want to talk to you guys about your facility was this renewable natural gas side of things, and how you have this really cool sustainability thing that's working with your fleet trucks and everything. Could you describe like what is going on here, one, and then how did you even come up with this idea? Like, where did this come from?
Oh, very good. I'll let Devin answer those questions.
Yeah, so how we came up with this idea, and it's somewhat unique the way that we came up with this, is because all of our utilities are under one umbrella. So it's under the environmental utilities umbrella. And a lot of the planning started for this back in 2016. And what we did back in 2016, we were actually looking to convert our waste collection fleet to be powered off natural gas, so compressed natural gas. And the reason for that was to reduce fuel cost and also have a cleaner fuel source. At the same time, the wastewater utility was looking at expanding the Pleasant Grove facility. So this is during the initial planning. And they started looking at different options to what to do with that excess gas to produce either energy at the plant or vehicle fuel. And what we came down to is we would produce vehicle fuel because it does two things. It gives us a stable price from a collection aspect for the waste collection vehicles. It provides us with a carbon neutral to carbon negative fuel, so we can actually be at basically a zero net generator of greenhouse gases once we have our truck fleet powered from this resource. And then it provides the wastewater utility with a better revenue source than just converting that to electricity. So it's like a win-win situation for both the utilities. It's pretty hard to make something like this work if we were completely separate. Like, for example, we had a private waste collection company and a wastewater utility. It's kind of hard to make that nexus for the two to work together. So we came up with this project and we started fueling our first vehicles just about 2 months ago. And we're looking forward to the next 10 to 20 years to be able to utilize this resource for both the utilities and using a carbon neutral to carbon negative fuel for our area here.
Yeah, it's a really incredible idea and use case for, I mean, capturing the gas and everything is is becoming more common, I think, for a lot of these facilities, but using it this way is really, really cool. What were some of the, like, how did you guys fund this? I think obviously treatment processes and making sure that you had the technology available would be important. Did you use any funding programs, or was this all done through taxpayers, or how did you guys fund this?
So I'll start this off and then I'll go ahead and pass it off to Bryan. So long term, we actually took out bonds and we looked at, we also have some grant funds available to fund this project, both local grants through the Air District and then some larger grants from the state. The long-term payoff of this facility will come from the cost of the fuel, basically what the refuse utility or waste service utility pay for fuel. And then in addition to that, there will be RINs credits through the federal government. And then there will also be LCFS credits, which are local here to California, that will help pay for this facility. It's going to be about a 20-year return on an investment for us to kind of seek the full financial benefit from the facility. So we're looking to stretch this out to 20 years. And there's been some recent regulations that have been developed in California. They're going to make that a little bit tougher for us, but we do have a strategy to make that 20 years. And Bryan, did you add anything to that?
Yeah, so we did get a pretty big grant through the California Energy Commission that paid for a portion of the costs. Most of the costs, the primary funding was through development fees. This project was part of an expansion project, and our capacity projects, expansion projects are all funded through our developments. We don't use ratepayer or the current customer funds to fund these kinds of projects. So this was just incorporated into an expansion project because we did have to do something when we started generating the gas as a part of this project, and so this fit right into that model.
Yeah. Well, one of my follow-ups was going to be the impact on your finances. And you mentioned like the ROI, the 20-year ROI, but the fact that you're reusing this renewable resource, I imagine over time is really going to start to show tremendous benefit on the finances and bottom line.
Yeah, absolutely. We did make a financial case for doing this, and it definitely, from what Devin said, it does have a payback. And so it does look like it'll pay for itself, barring any craziness at the state level from a regulatory standpoint. But yeah, I think we're in good shape.
Yeah. Do you see any additional optimization that is available with your current technology and things like that? Like, is there a way to get more fuel out of it or optimize it for even further than what you have it set to at the moment?
Yeah, absolutely. So if, in the event that there is more demand for RNG than what we have trucks for right now, we have the ability to feed high strength waste. We have the ability to feed food waste. So we are currently feeding high strength organic waste. So, things like renderings, grease interceptor pumpings, things like that, that increases gas production. So we have the ability we have a facility that receives that material. And then in the future, we'll also be receiving food waste, which will, again, it'll increase that gas production as we add more trucks to the fleet and find more outlets for that fuel.
Yeah, just building out your co-digestion program.
Correct.
Yeah. So what challenge did this project present to you guys in terms of like the engineering or the design, and how did you overcome any of those hurdles?
So it had the traditional difficulties that you have with a large wastewater treatment plant. One of the challenges was that this was an existing operating wastewater treatment plant. So all of the improvements had to be done while we're operating an existing plant. But I think some of the biggest challenges were how to operate the gas system. So we have the system that produces the compressed natural gas for the trucks, but we also have a system that is connected to that takes what we call the tail gas, or the little bit of the waste gas that is produced in that conditioning. And we take that and we add a little bit of utility gas and we run microturbines to generate electricity. So running all of this all together was a fairly complex engineering exercise. And when it first got commissioned and was operational, it did take a little bit of time to work out the bugs from an engineering standpoint and a tuning standpoint. So, but we're there now. So
yeah. Yeah, and like you said, there's still potential final additional tweaks you can make to really optimize that even further too. So, what's next on the roadmap? I mean, sounds like such an achievement to be thinking about what's happening next already. But so, congratulations first on the achievement that you've reached. But what are you working toward next? What's next for the city of Roseville?
So right now, Roseville is still growing. At least from a wastewater standpoint, we're still a growing community out in the region that we serve. So right now we're looking at making sure we have capacity, for that growing development, and continue to produce and be green. I think that, as we move into the future, if the challenges that Devin described with the regulatory side of things, where we may see electrification of the refuse fleet, we may need to find alternative outlets for our gas. We always know that we have a demand for electricity, but there are other opportunities, and so I think we're gonna definitely be looking at that into the future.
Yeah. Awesome. Well, I'm glad you guys are so forward thinking, and even though you've, like I said, you've made a really cool achievement here. But I do appreciate you both taking the time and talking with me. Thank you so much for your time.
I appreciate it. Thank you.
Thank you.